Hi, everyone. Just wanted to talk briefly about dealing with the standard form of a quadratic function and how that relates to actually graphing the quadratic function. So I think there's a couple important pieces of information that we can get just in general that'll help you significantly when you are dealing with graphing these functions. So let's first make sure that we are clear. The standard form of a quadratic function is f of x is equal to ax squared plus bx plus c. We are saying that a is not equal to 0, and the reason behind that, as always, is just that if a was 0, we would have a line, right? Because this would be bx plus c, which would just be the same as mx plus b, right? So there's a couple pieces of information that we can obtain just from looking at this immediately without doing a whole lot of work. So we can see that if I plugged in f of 0, right, we're saying that the value of c is the y-intercept of the graph. Now, the reason behind that is because if I plug in f of 0, I get a times 0 squared plus b times 0 plus c, and that's gone, and we're just left with c. So my y-intercept, that's just going to be 0, c. All right, and then that's where, again, that's where the parabola is going to intersect the y-axis. The other thing that we can obtain from this is you'll notice it's very similar to the forms that we've been using when we've been factoring. And as you know, the x-intercept is when y is equal to 0. So if I just set the whole thing equal to 0, and then we solved it by factoring or using the quadratic formula or completing a square or square roots or any sort of method that we have used, we'll be able to get the x-intercepts. So the x-intercepts, those are just going to come from, factoring, right? Factoring, solving, using the quadratic formula, any of those, something like that. So that's one benefit to being in this form. Another thing that we can tell right off the bat here is we are dealing with, something with an a out front. And I will tell you, we do know that, when a is greater than 0, it goes up. And then when a is less than 0, it's going to go down. Okay. So that is still going to affect that. And a is also going to affect the width. And by that, I mean, if you have a big a, it's going to be super skinny. If you have an a that's close to 0, it's going to be wider, things like that. All right, so let's look at what else it has to say. It says that the axis of symmetry of the graph is the line x equals negative b over 2a. Now, you're probably asking yourself, well, what the heck does that mean, and where does that come from? So essentially, what is happening with the axis of symmetry is if I have a parabola, opening up in this case, the axis of symmetry is the line I could fold the parabola over and get a perfectly matched copy. So it's going to go through the vertex, right? Because if the vertex is either the lowest or in the case where it opens down, the highest point. So it would need to perfectly go through the vertex. And then if we folded it over, we would get a reflection, right? So that does help us out with plotting this graph, because if I went over, 1 here and I got to this point, if I went over 1 here, it's going to have the same y coordinate. So that's why we care about the axis of symmetry, because it essentially means we only have to do half the work, right? I only care about this side. Once I get this side, the other side is easy. All right, so where does this negative b over 2a come from? Well, to answer that question, I want you to think about when we were solving to figure out the quadratic formula, and we were completing the square. At a certain point, we got to this step, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, you're probably looking at this and going, okay, yes, well, why didn't you just write everything over 2a? And I just want you to pay close attention. This is the same thing as what we just said the axis of symmetry was. And that kind of intuitively makes sense, right? Because if we're dealing with negative b over 2a, then we're adding and subtracting something from it. So if we add the square root of b squared minus 4ac over 2a, that's like going to the right by this amount. And then if we subtract it, it's going to the left by that amount. So it makes sense for this right here to be kind of our focal point, right? That's our middle point. I shouldn't use focal point. That has a specific meaning in parabolas. But so this is kind of our point that we're dealing with. This is the center that we're basing everything off of. So everything's going either left or right of this value. And then obviously if you use these would be the X-Intercepts. So right there. But ultimately, that's where this axis of symmetry is coming from, because this point right here, you're adding and subtracting from this point to go left or right. And if you go to the right by 2 from this point, you go to the left by 2 by the same from this point as well. And then whatever you have in terms of your x values, if you go over 2, whatever your y value is the same as if you went to the left 2, right? If you went right 2, left 2 has the same thing because that axis of symmetry. All right, finally, last thing it tells us, that is the x-coordinate of the vertex. Well, that's good. So that is the x-coordinate of the vertex. Again, this would be our vertex right here. As we just said, it has to go through the vertex. Otherwise, we would have a side that doesn't match up with a different point because the vertex is the lowest or the highest point. Now, if that's the x-coordinate, we have to think about, well, what's the y-coordinate? So we're given an x value. We're saying x is negative b over 2a. When I have an x value, it's easy for me to find a y value. I just plug it in. It might not look easy, but it is actually straightforward enough. So if my vertex has the point negative b over 2a as my x value, my y value is just when I plug that in. So I plug in f of negative b over 2a. So all I'm saying by that is if my x value is 3, I just plug in 3 and then whatever I get. So it would be a times 3 squared plus b times 3 plus c, and so on and so forth. So that covers most of the general information that we are going to get from the standard form of a quadratic function. And you can actually use this to plot any quadratic function. Exactly what your coordinates are going to be are not always the same in terms of ease of graphing, but ultimately this will work every time. So let me scroll down and let's look at an example. Okay, so we are now dealing with a situation where we're given a quadratic function in standard form, 2x squared plus 4x plus 3. And we are tasked with finding the axis of symmetry, the vertex, and the y-intercept of the function. And we're going through a couple of different steps that we're actually going to get to use in order to figure this out and then make a nice sketch, or graph, I should say. All right, so first, we are finding the axis of symmetry. So we know from above that the axis of symmetry is this vertical line. Now, if you're still getting used to this form, it might be beneficial for you to identify A, B, and C first. So A being 2, B being 4, and C being 3. Okay, so once we plug that in, that would be the same thing as negative 4 over 2 times 2. That'd be negative 4 over 4, which is negative 1, right? So I know if I went to negative 1 here, this is going to be my axis of symmetry. This is what I'm folding everything over. All right, step 2, plot the vertex. Well, I already have the x value of my vertex, so that's good. So it's negative 1, f of negative 1. Now, we have to figure out what f of negative 1 is. So we'll plug it in. F of negative 1, that is just 2 times remember it's -1 all squared, not just 1 squared times -1 all squared, plus 4 times -1 plus 3. So that's just 2 because -1 squared is 1, minus 4 plus 3, which is -1. All right, so we end up, +1. So we end up in a situation where we have the vertex being -1, +1. All right, so I go there, 1. And that makes sense. It should be on our axis of symmetry, as we stated from before. So plot the y-intercept in its reflection. All right, well, we already know right off the bat that we can say that our y-intercept is going to have the y value of 3. So it's 0, 3. Now, the tricky part here is that we are dealing with 0, 3, right? So we've dealt with that, but now we have to, it's also telling us to plot its reflection. So what does that mean? That just means I went to the right one, and if I reflected that over the axis of symmetry here, I would have to go to the left one. When I go to the left one, I'm going to be going up the same amount. So I went over to the right one, up 3, and I'm going to go over to the left one. And we're going to the left one from -1. So -2, 3 is also a point. You can do the same thing if you went over 2, right? If I went over 2, I could figure out what that is. And then go over 2 to the left and figure out what that is based on exactly what I got on the other side. In fact, let's do that one right now, because step 4 is saying do with another point. So 4. I'm going to recommend we just go over 2. So 1, 2. So that would be over to 1. Doesn't matter what you pick, but I'm just picking 1 for simplicity. Pick nice points. Don't do more work than you have to do here. The other thing to consider as well is just because +3. Just because you have 1 as an option doesn't necessarily mean it would make the most sense to always choose 1. I'm saying picking 1 is kind of generally easy. However, you should try and pick the points as close as possible to the vertex, just because those are going to be the closest to the vertex in terms of what the y value is going to be, right? So if you had a y value of, here it's 1, you know that everything close in between here is going to be between 1 and 3, right? If you went over here, it's going to be farther away and it's going to be further up. So try and be as close as possible to the vertex when you're picking other points. So here we went 1 away and got to 0 and got to the intercept. But if we had gone 1 away and we weren't at the intercept yet, maybe go 1 away. So if we had started at -2, go to -1. That's going to be an easy point. All right, anyway, so you plug that in. We're just plugging in 1. So that is 2 plus 4 plus 3, which is going to be 9. So I get the point 1, 9. And as stated, I went over 2 to do this, so let's go over 2. 1, 2. So 2 from -1 is -3. And what I did there, it's going to be the same thing. Up 9. All right. And now we have our sketch. And try to make it as rounded as possible. Try not to make it too V-E. That's not a word, but try to round this as much as you can, okay? Don't necessarily make it a V shape, because that would be the absolute value function. I know it's a little bit harder with A's that are bigger than 1, but do your best. All right, so let's give you one more chance to try that before we end for the day. So right now what you're going to be doing is you're going to find the vertex of the graph of the quadratic function. You're going to determine whether the graph opens upwards or downwards, and then you're going to find any intercepts and sketch the graph. So let's start with the vertex. So the vertex for this one is going to be found the same way that we find the vertex in any other situation. So my vertex is going to be negative b over 2a. And then if I plug in negative b over 2a. So what's negative b over 2a? Well, that is going to just be negative 12 over 2 times 3, which is 6. So it is negative 2. Now we have to find f of negative b over 2a, which is negative 2. So we have to find f of negative 2. We have to be careful to make sure we write this down correctly. So it is 3 times negative 2 squared plus 12 times negative 2 plus 14. All right, so we get, remember it's negative 2 squared, so that is 4. So that'd be 12. It's horrible equals, but it isn't equals. 12 times negative 2, which is negative 24, plus 14. Okay. So we have 12 plus 14 would be 26. 26 minus 24 is 2. So my vertex is going to be negative 2, 2. Okay. So if I were to start off with my quick sketch, negative 1, negative 2, 1, 2. Here's my vertex. Again, the axis of symmetry goes through the vertex. So there's our start of our graph. Now, we're looking also to determine whether or not it opens upwards or downwards. So how do we do that? We look at A, right? A is greater than 0. And because it's greater than 0, it is going to open up. It's being very laggy. So it's going to open up. Okay, so we know it's going to open up. So that automatically does mean that if I tried to factor this, it's not going to work. I'm not going to get any real solutions, right? It's never going to cross the x-axis. So we could factor it all day, but it's not going to work. If you use the quadratic formula, you're going to get a negative under the radical, and so you would have no real solutions. Okay, so find any intercepts. We already know that there's going to be no x-intercepts based on the analysis that we just did with A and what my vertex was. So we can find that we have C, 0C. So if I went up to 14, oh geez. And remember, we went over 1, 2 for that. So if we went over to negative 3, negative 4, that would be the same, right? Now, for good measure, we can find another point, just for sketching purposes, to kind of round it out a little bit. So this is exactly what I was talking about last time. We started at negative 2, and then our intercept was at 0, which is 2 away. So if we went 1 away, we get a point kind of in between them, right? So I'm actually going to choose as my point to plug in negative 1. So if I plug in f of negative 1, that's going to be 3 times negative 1 squared minus 12 plus 14. And that's ultimately going to be negative 1 squared is still 1. So we have 3 minus 12 plus 14, which will be 5. Okay, so we know we have the point negative 1, 5. 1, there we go. This is just a sketch, so it's okay. You don't have to be perfect with my counting. Really, the forcing method should be a little higher up, but that's okay. All right, and then negative 1 I'm sorry, we have to go, if we went to the right one, we can go to the left one and get the same y value, right? So if we went over to the -3, we'd have the same y value. So then when we sketch, it's going to look up like that. Okay. And there you have it. All right, I hope this helps. And that if you have any questions, please let me know. Have a great day.